Hi students, today we are back with another problem from law of chemical equation. Okay, here potassium chlorate is decomposed to give oxygen gas in the presence of catalyst manganese dioxide. So we need to calculate the following details. First of all, calculate the mass of potassium chlorate required to produce 6.72 liters of oxygen at STP. Okay, so if you observe the equation keen, it is evident that when 2 RMM of potassium chlorate react, we get 2 moles of KCl and 3 moles of oxygen gas. Okay, so let's proceed by calculating the RMM of all the compounds given in the question. I hope you must be knowing to calculate the RMM. Let's try solving it. So here it is 2 moles. Okay, so 2 is common for all the element. 2 into mass of potassium is 39. So 39 plus, here there is only one chlorine atom and the mass of chlorine atom is 35.5 plus. Here there is 3 oxygen atoms, so 3 into 16. On calculating, this would be around 245 grams. Okay, so the RMM of 2 KClO3 is 245 grams. Okay, so let's write it down. Mass is 245 grams. Okay, in a similar fashion we can calculate the mass of 2 KCl, which would be about 149 grams. Okay, similarly the mass of oxygen would be 96 grams. This is a preliminary step which we have to do. Now we can calculate the mass of potassium chloride KClO3 required to produce 6.72 liters of oxygen gas. Okay, it has been observed that when 245 gram of KClO3 react, we get 3 moles of oxygen gas, right? We already know that 1 mole will occupy 22.4 liters. Okay, therefore this 3 moles will occupy 3 into 22.4 liters. That is, when 245 gram of KClO3 react, we get 3 into 22.4 liters of oxygen. Okay, which will be nearly 67.2 liters. 67.2 liters. That is, when 245 grams of KClO3 react, we get 67.2 liters of oxygen. Now we need to calculate the mass of KClO3 required to produce 6.72 liters of oxygen. That is what is being implied in the question. Okay, so let's proceed to solve it. So now we are going to make the comparison based on, here we will take mass of KClO3, and here we will consider volume of oxygen gas. Okay, we have already discussed that when 245 gram of KClO3 react, we get approximately 67.2 liters of oxygen, isn't it? In the previous slide we have discussed that when 245 grams of KClO3 react, we get 67.2 liters of oxygen. Now we need to find the value of KClO3 which will produce 6.72 liters of oxygen. Okay, simply on cross multiplying and solving, we will get X as 24.5 grams. Okay, we will get it as 24.5 grams. That means 24.5 grams of KClO3 is required to produce 6.72 liters of oxygen according to the given equation. Okay, I hope it's clear now. We have made the explanation from the question. When RMM of KClO3, that is when 245 grams of KClO3 react, we get around 67.2 liters of oxygen. From where is the 67.2 liters arrived? Here the number of oxygen molecules released is 3. We already know that 1 mole will occupy 22.4 liters. So 3 moles will occupy 3 into 22.4 liters, which will be 76.2 liters. That means when 245 grams of KClO3 react, we will get 67.2 liters of oxygen. So now we need to calculate the mass of KClO3 which will produce 6.72 liters of oxygen. Okay, just cross multiplying, we get X is equal to 24.5 grams. Okay, that is 24.5 grams of KClO3 is required to produce 6.72 liters of oxygen at STP. I hope it's clear now. And the next question, we are asked to calculate the number of moles of oxygen present in the above volume. Okay, here the volume is given 6.72 liters of oxygen. We need to calculate the number of moles as well as the number of particles. Okay, so now we are going to make the comparison based on, See, we know that 22.4 liters is equivalent to 1 mole, right? We have already discussed the details about this in the first video. Since 22.4 liters is equivalent to 1 mole, we now need to find how many moles of oxygen will be present in this 6.72 liters of oxygen gas. 6.72 liters of oxygen gas will be constituted by how many number of moles. Okay, so we need to just cross multiply it. Okay, on cross multiplying we will get x is equal to 6.72 divided by 22.4, okay, which will be 0.3. Okay, so the number of moles of oxygen present in 6.72 liters is 0.3 moles. Moreover, we have to calculate the number of particles present. Okay, we also have to calculate the number of particles present in this same volume of oxygen. We know that 1 mole of any substance will contain Avogadro number of particles, right, which is 6.022 into 10 raised to 23 particles. We know that 1 mole of every compound will contain 6.022 into 10 raised to 23 particle. Here we have seen that the number of moles of oxygen is 0.3. okay, number of moles of oxygen is 0.3. so we need to calculate this number of particles present in 0.3 moles of oxygen. So let it be x. On simply cross multiplying, we get x is equal to 0.3 into 6.022 into 10 raised to 23, which will be around 1.8066 into 10 raised to 23 particles. Okay, this would be the number of particles present in the above given volume of oxygen gas. Okay, the problem is quite simple if you once know the basics of the problems related to law of chemical equation, which we have already discussed in the first class. Okay, since 22.4 liters of every compound will be considered as 1 mole, we need to calculate the number of moles present in 6.72 liters. And since 1 mole of a compound will contain 6.022 into 10 raised to 23 particle, we need to calculate the number of particles present in 0.3 moles of oxygen gas in the given question. Now the last question, we need to calculate the volume occupied by 0.01 moles of carbon dioxide at STP. Okay, we know that 1 mole of carbon dioxide will occupy 22.4 liters, right? Now we need to calculate the volume occupied by 0.01 mole. 0.01 mole will occupy, say, x liters. On simply cross multiplying, we get x is equal to 22.4 into 0.01, which will be about 0.224 liters. Okay, this is also from the basics. We already know that 1 mole of a substance will occupy 22.4 liters at STP. Okay, now we are asked to calculate the volume occupied by 0.01 moles of carbon dioxide. So let's consider it as x. On simply cross multiplying, we get x is equal to 0.224 liters. Okay, so the volume occupied by 0.01 moles of carbon dioxide at STP is 0.224 liters. I hope this question is clear.